Hi, I'm Priyanka Sarya. In this video, we will be using SAS Enterprise Miner to analyze a wine quality dataset. The quality of wine is generally assessed by sensory or physiochemical methods by trained panelists. But this method is expensive and time consuming. So we will be using decision tree and neural network to infer the quality as perceived by a wine drinker, but using physiochemical characteristics. The wine quality dataset is taken from UCI machine learning repository. We will be doing an experiment on the quality of red wine for this assignment. SAS Enterprise Miner uses sample, explore, modify, model, and assess. I will show decision tree neural network applied on this wine dataset and also explain four main concepts of entropy, misclassification, backpropagation, and ensemble in this video. I have already prepared my model and executed. I will explain each node of this experiment one by one. First node is the file import, where you can select a file from your computer. Once selected, we can right-click and edit variables of your input dataset, update the role of each variable as input, target, or rejected. I have set quality as my target variable, rest all of the variables would be my input variables. Next is the stat explore node that generates a descriptive statistics of the input data. If you right-click results, it will show you a graph of variable worth. That is a plot of the orders of the variables by their worth in predicting the target variables. Our next node is the data partition. We will be partitioning our data set into three sections. First would be training 40%, validation 30%, and test 30%. Our next node is impute. In impute, we basically replace the missing values. It would be replaced by the mean of that column. Next, I've used decision tree to predict the wine quality with the maximum depth of 6, which I have defined here. This is used to define the depth of the tree in order to eliminate overfitting. The decision tree is pruned after 6 generations. Pruning is done to avoid overfitting. The decision tree algorithm constructs the tree by recursive subdivision, selecting the most influential attribute from the training instances at each node and splitting each set of instances into subsets with high and low values of that attribute. Each of these subsets then becomes a child node. After subdivision is complete, all the instances are distributed across the leaf nodes. Overfitting happens due to oversplitting of the parent node into child nodes again and again. Pruning is done to avoid overfitting. If we look at the ordinal target criteria, we see two options, entropy and Gini. Entropy is for exploratory analysis. It is used for attributes that occur in classes. Gini is to minimize misclassification. It is intended for continuous attributes. These two measure the quality of subdivision of sets of items in a decision tree. Entropy will be our first concept. Let's get to the neural network. We will discuss our second concept of misclassification, which is in the model selection criteria. Misclassification should be kept to the minimum so that we get a better model that helps to get better rates of true positives and true negatives while minimizing the false rate part. When we right-click on the neural network, we can go ahead and see the results of the neural network. In the fit statistics, we can see different statistics label such as mean squared error, average error rate, error function, etc. Also, you can look at the local optimum value which reduces the average squared errors. The next concept that can be explained is backpropagation in neural networks. A neural network propagates the signal of the input data forward through its parameters towards the moment of decision, and the backpropagation information about the error to the network so that it can alter the parameter one step at a time. So, in simple words, a neural network tries to find a better value of its parameters by going back and forth again and again. Next is a control point from where we can converge the input and then distribute the output. We will next discuss the ensemble, which could be our fourth concept. Ensemble combines the probabilities of two models used here to give a better model. Its main idea is to combine weak learners to get a strong learner. Ensemble has to have diverse models in it, that is, it should have two different models of to give better accuracy. The last node here is the model comparison, which compares the output of the decision tree, neural network, and the ensemble. You can see the results of the model comparison of these three different models in the fit statistics. The average squared error is is maximum in the decision tree and lesser in the neural network. Thank you.